must specify the primary index explicitly. Okay. We'll see now what will happen if we are not specifying and what are the rules the system is going to consider. Okay.
Okay.
In terms of the SQL which we are using, it will be similar almost in every of the any of the RDBMS concept things. Okay. So nothing to worry about the SQL, how to write the SQL in Teradata. Okay, it's almost similar.
Okay, Shashi.
Now I have dropped this table. So when I was creating it yesterday, what was the column it was selecting? It was selecting customer ID column, right?
Yeah, correct.
Now let's say I am planning to make one of these columns as a primary indexed column. I am making age column as a primary indexed column. Sorry, primary key column. I have defined one of the column in the table as a primary key column, but I am not specifying any column as a primary index explicitly. Okay. During the table creation time, I am not specifying the primary index explicitly. For executing any query on SQL Assistant, you need to use F5 key on the keyboard or you need to use this button. Okay.
Okay. Okay.
So the table has been created, right?
Yeah.
Now I am doing a show table. Show table database name dot table name will give out the DDL that was used for creating of that particular table. Show command is the one that will be used for seeing the DDL that for that particular object that has been created. Okay.
Okay.
So when I say show table, it is giving me this one. Let's see what is the difference it has from the one which we have used for creating. So did I specify the age column as the primary index explicitly while creating the table?
No.
But it has taken that age column explicitly, right?
Yeah.
That too it is a primary indexed column. Okay.
Correct.
That it is a primary indexed column. So when I am not specifying the primary index explicitly, so the system will check for are there any columns defined as a primary key column on the system in that particular table.
Okay.
If I see like any of the column is defined as a primary key column, and if there is no explicitly defined specified primary indexed column, then that particular column is whatever the column defined as a primary key column will be considered as a primary index column of the table.
Okay. Okay.
So what is the reason behind choosing the primary key column as a primary indexed column by the system? Because the reason is the data in the primary key column will have a uniqueness in nature, right? So
Correct.
it could be a good candidate for distribution of the data. So that is the reason why the system has given the first preference to check for existence of any primary key columns if
Okay.
there is no explicitly specified primary index. Okay.
Okay. Yeah.
Now I am dropping the table again and I am recreating the table without the primary index. This is scenario number 2.
Okay.
I'm making years with bank column as unique constraint. You might have heard of the concept called unique constraint, right? Where whenever you define any of the column as unique constraint, it will not allow any duplicates. And
Correct.
similar, whatever the constraints, primary key constraint, unique constraint, not null constraint, all these are the ones that will be similar across all the databases, whether it can be Oracle, it can be SQL Server, or it can be Teradata.
Okay.
Why
Okay.
they should be same in nature? Why all the databases should support all these constraints? Means for in India, for approving anything, we have the ISI mark, right?
Yeah.
Indian Standard Association is the one that will support with ISO standard, ISO certification, or the ISI certification for all the products which will be sold out in India, whether it can be a water packet or whether it can be a any food item or whether it can be anything.
Mm-hmm.
Hallmark is the one that will be certified for the gold, right? For
Correct.
the gold and silver items, right? For everything we have a standard authority. Like for the languages, you will be having ANSI, right? For databases also, it will have it will follow a standard called ANSI standards.
Yeah.
Okay, so that is the reason why every database will have certain common features, like in terms of these chord rules or these ANSI standard rules, in terms of like primary key notations, all these things. So now when I say show table, what is the primary index it has selected? What is the primary index it has selected this time?
Actually, sir, sorry, Chaitanya.
Yeah.
For couple of minutes, I was not able to hear you. It was completely blank.
Is your network strength is good?
Yeah, it was fine.
Okay. So when I define any of the column as a unique, is it audible now, right?
Yeah, yeah, now it is fine.
Okay.
Yeah, when you were
So
telling about the hallmark, right? So that time it stopped
okay, okay.
actually.
So that is the standard. So similarly, in terms of the databases, we have the standard authority, that is the ANSI. So all the databases will follow the ANSI standards. Okay.
Okay.
So here when I say show table, I have defined the years with bank column as a unique constraint. And when I create that particular table and there is no explicitly specified primary index.
Okay.
Okay. In that case, it has pulled out the column years with bank which has been defined as a unique constraint. It has taken that particular column as the primary indexed column.
Okay.
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 Here if you see like what is the type of primary index you are seeing here? It's a unique primary index, right?
Yeah.
It's a unique primary index column that has been defined on the column which is a unique constraint defined column. So if there is no primary index explicitly specified and if there is no primary key, then the second preference it is going for unique constraint.
Okay.
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 Second preference is gone for the unique constraint. Now again I am dropping it. Let's see what will happen if we specify both the things. Now I have specified primary key as well as unique constraint. but there is no explicitly specified primary index, right? I have specified primary key on age column. I have specified unique constraint on years with bank column. So which one is going to take the precedence? Is it the primary key or is it the unique constraint? Which will be the column that will be made as a primary indexed column? Any guess? Rajesh? Hello? Rajesh? Hello? Rajesh, are you able to hear me? Ishwar,
Hello.
I think there is some problem with the network connection with Rajesh.
Yes, 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 yes. Because there is no power. In Raj's home, power is not there. That's why.
Okay.
I think Rajesh is arrived. I think.
Yeah. The age column with primary key and years with bank column as unique constraint.
Okay.
Okay. So here I am defining these two columns, one as with primary key and other as with unique constraint. Now I have created the table with this definition. So which
Okay.
column is going to be made as a primary indexed column and why? Any guess?
Uh, might be age.
Might be?
Age.
Okay. So what is the specific reason like why the system is going to select only the age column? Because is it like the primary key is the topmost column and started searching from the top? Is it the reason or
No. Primary key is something which. Okay. So both will have not null and
both are having the same not null primary key, not null unique constraint?
or could be a combination of both.
It will take a combination of both.
Yeah.
For a table, how many primary keys you can have?
Only one.
Only one. How many columns combination it can allow? Composite primary key?
Mm, that uh, that depends.
Sorry?
No, but it can allow.
Okay.
Uh,
Here it should take either age or years with bank only, right? Because both are of
mhm.
different conditions.
Okay.
If it is taking a composite means, it should be defined as a single one. I should have defined it as on a combination explicitly.
Oh, okay, 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 okay. So then, yeah, it should take either one.
Sorry?
Yeah, that is correct. So it should take either one.
It will go with the
It should take. Okay, the primary key. I guess it should go with age only because it is non-unique and it might have some standard. I mean, like
no, don't
it'll be.
consider about the data that is coming into each column. Okay?
Okay, okay.
Because okay, as per you, you are telling like age can be having duplicates, right? Will the
Yeah,
primary key allow duplicates? It will never allow
yeah,
any kind of duplicates, right? The
correct,
value that is getting into age column should occur only once. If it is getting
correct.
only once, it will allow. If it is
Yeah,
coming for the second time, it will error out, right?
correct, correct.
Here in my case, there are no erroring out. There is no erroring out happening. All the values that I'm getting in age column or years with column are unique
Mm-hmm.
because
Okay,
the file has arrived in such a way. Okay.
okay,
So
okay.
which one it is going to consider? In that case, the job itself or the loading or the insertion of that particular value itself will fail, right?
Correct, correct.
But here still we are in terms of creation of the table.
Correct, correct.
Rajesh?
Yeah, okay, so both will have same features, but primary key is something which can easily identify. So not unique. Uh, Primary key is, I mean, like maybe it is like it will arrange it in some sequential order. I mean, like no, that is primary index.
It's not going to be sequential, right?
Yeah, correct. So, actually can't say
What
exactly.
were the first two cases we have discussed before this case scenario? We have discussed two more scenarios prior to this, right?
Yeah.
What are those two scenarios? If you
So
think in that way, you can get it.
one was not null primary key, the other one was not null unique.
Even if I am not giving not null also, primary key will not allow any kind of null values. If I want
Correct.
to define any key primary column as a primary key column, I should define it as a not null
Correct. Correct.
because it will expect a value into it.
Yeah. Good. So, mhm, okay. So then, not sure. Okay. So, uh, not sure actually.
Sorry,
No, kind of not sure. Mm,
Rajesh, are you using the headset or are you using the inbuilt mic?
I'm using headset only.
Okay, because the reason is that your voice is not at all clear.
Oh, is it clear now?
Yeah, it's a bit okay.
Fine now?
Yeah, it's fine now.
Okay, okay. Actually not sure what, uh, kind of not sure actually.
You are from
Mm,
Bangalore or you are from AP?
no, Bangalore.
Okay.
Mm, small and, okay. The data type is same. Not null, primary, null unique. No, not sure, Chaitanya.
Okay, let me do the show table. So what we are seeing here, we are seeing unique primary index on age column, right? So it has
Mm-hmm.
taken the primary index on age column,
Mm-hmm.
which is the primary indexed column. Whatever the other index it is showing, it's not the primary index, it's the secondary index. We'll discuss it on later point, at later point. Okay.
Mm-hmm. Okay,
So
okay.
it has considered the age column as the primary index. So you may think like because the column age is appearing for the first time in the first in the order. So you may think like that, right? Let me change this column to topmost one in the list so that it can clear if any minor confusion exists. Still it is taking
Age.
age itself as the primary index column. So as I told you in the first scenario, the first thing the optimizer will check during the table creation time, if there is no explicitly specified primary index, the system will check for existence of primary key column. Any of the column is defined as primary key. That's what the thing I told with scenario 1, right?
Yeah, correct.
So whatever be the order, if there are n number of constraints defined on it, n number of key columns are there, but it will check for the existence of the primary key column for the first time as a first preference.
Okay, okay,
Okay. So that is the reason why it has taken the age column as primary indexed column, which what are the column that has been defined as primary key.
okay,
If I have both the columns like primary key column and unique constraint column, whatever with the primary key column you have defined as whatever with the column you have defined as primary key, that column will be made as the primary indexed column. Other columns will be treated as secondary indexed columns automatically by the system. There is no need to specify them explicitly.
okay.
Now I am going to drop the table again and I am going to create it once again. This time I am not going to specify any primary constraint or anything. Here in the earlier cases, the primary index is of unique primary index, right?
Yeah,
Now see, I am not specifying any primary index or unique constraint columns. The table has been created, right?
yep.
So what is the primary index it is showing? Now we'll see. I have not specified the primary index explicitly. So it has taken the primary index on its own. So if I'm not specifying the primary index explicitly during the table creation time, the system will check for the existence of primary key. If it doesn't have primary key, then it will check for unique constraint columns. If it doesn't have unique constraints defined columns, it will have its own default rule. What is the default rule it is going to apply? Means whatever be the first column in the table, that particular column will be made as the primary index of the table. Clear? If there are no
Uh,
primary key, yeah, go ahead with your question.
no, yeah, so, okay, so let's say if customer ID is the first column, but if it is not null, then will that still be as a primary index?
Whether it could be a nullable or whether it can be a not nullable column. Whatever
Yeah,
be the
correct.
first column, it will take it as a primary index column. It doesn't bother the nature, whatever be the data type, whatever be the size of the column, whether it is a nullable or not nullable column. Okay, it will
Okay,
consider the first column itself as the primary indexed column. If you notice that the primary index that was chosen, it's a non-unique primary index. You will not able to see the
Mm-hmm.
unique keyword before the primary index, right
Okay,
or wrong?
okay. Correct, correct.
Whatever
Correct.
the primary key columns, unique constraint columns that were made that were chosen as a primary index, in those cases it is taking the unique primary index because it is sure that it's going to get only the unique data because of the nature of the constraints, because primary key or unique constraint will never allow duplicates, right?
Correct,
So
correct, correct.
based on that, it has chosen the primary index as unique primary index. But here in this case, when the system is selecting a not non-primary key, non-unique constraint column as a primary indexed column, in that case, it is making the primary index as non-unique primary indexed column.
Okay, okay.
The reason is in order to accommodate the null values or duplicates that are coming into, or in order to accommodate the duplicates that are coming into the table data that were coming into the primary indexed column.
Okay,
Okay.
okay,
So when the system on its own selects the primary key column, primary indexed column, then it will consider it as a non-unique primary index one. Okay.
okay,
So what is the difference between a unique primary index and non-unique primary index? Unique primary index will never allow any kind of duplicates into that particular column which is defined as primary index. Whereas the non-unique primary index will be used for, will allow any number of duplicates. A single value can repeat n number of times. That value can be duplicated n number of times. Okay.
okay,
So
okay,
the advantage of unique primary index is it's going to distribute the data uniformly across the system, across the AMS in the Teradata system. Whereas a non-unique primary index may distribute the data across the uniformly across the system or may not be. What could be the reason means it depends on the number of duplicates that were coming into that particular indexed column. So how it is going to affect, why the duplicates in the primary index column are going to affect the data distribution. As I told you, like the prime in Teradata system, it will internally use an algorithm called as a row hashing algorithm, right? In Teradata system, the data will be distributed across all the AMPs by means of the row hashing algorithm. Whatever be the address that was given or the value that was given as an output by the row hashing algorithm, that value will be used to map the record to a AMP in the Teradata system.
okay,
Okay. So let me show you. Let's say I have a value 10. Hash row is a function in Teradata system that will give out the row hash value. If I am giving this value 10 to the row hashing algorithm, it will give out this value. It is going to be a hexadecimal value that is of 32-bit. It is a 32-bit value which will be shown to us as a hexadecimal value. Okay.
okay,
This is the value. If I am passing this value 10 for 10 times, if I am passing this value 10 for 10 times or 20 times, will it change the value, row hash value that it is giving? It is going to give
okay.
out the same, even
Yeah,
if I am passing it for 100 times,
correct.
right? If I'm passing it for 100 times also, it's going to give me out the same value. That is going to be the same 32-bit value, which is going to be this one in terms of the hexadecimal representation. Okay. So this is the row hash value which was given out by my algorithm. So when the algorithm gives out this 32-bit value, it is called as the row hash value. So for the algorithm, we will be giving the primary index column value. Whatever be the value you are passing to the primary index column, that value will be given as an input to this row hashing algorithm. Based on that value, it is giving the 32-bit value, which is called as a row hash value. What is the output that was generated from the row hashing algorithm will be called as, it is called as a row hash value. It is a 32-bit value. Out of this 32-bit value, the first 16-bit will be called as DSW. D means destination, S means selection, W means word. The first 16-bit of the 32-bit value is called as DSW. So what is the destination we are going to find? We have the 32-bit row hash. Out of that, we are using the first 16-bit to find out our destination. So what is the destination here for us? The destination is going to be the AMP number where the record is going to be inserted. Clear? Rajesh? Rajesh?
Okay, got it, Chaitanya.
Okay.
Yeah, got it, Chaitanya.
Okay. So that is AMP number is the one which is going to be our destination where we are going to insert the record in case of insertion. If it is a retrieval also, it will be the designated AMP from where we are going to retrieve the record. That is the case in terms of retrieval if it is a select statement. And if you are using the PI column in your where clause. Okay. So that is our destination. So whatever be the first 16 bit, we have a configuration map that will look like this. So we have a configuration map which is called as a hash map. Okay. We have a configuration map that is called as a hash map that will map this row hash value to a designated AMP in the Teradata system. So you are seeing some boxes kind of things in this hash map, right? It is a matrix kind of structure where you are having some box kind of structures, right? There are some cells in this map, right? Each cell is called as a bucket. What it is called as? It is called as a bucket, hash bucket. It is called as a hash bucket.
Okay.
Whatever be the
Hash bucket.
value you are seeing in the cell, in the intern the bucket is the AMP number. The cell itself is called a bucket. The bucket is holding the AMP number on which the record will be inserted or from which the record will be retrieved. So this is the 32-bit value we are having. Out of that 32-bit, 16-bit we are calling it as the DSW, right? So the 16-bit is 691B. Out of this 32 bits, value 691B14AE, the first 16-bit, the first half is 691B. Have you ever used the algorithmic books in your academics? You might have used the
Yeah.
algorithmic books, right? So for looking
Yes,
for
sir.
10 degrees to 2 minutes. So you'll be looking at 10 degrees and 2 minutes like this. Wherever the value intersects, that is the value that is going to be the value of 10 degrees and 2 minutes. right?
Correct.
Similarly, 691B, this is intersecting at this particular bucket, right? 691 here and B. This is the bucket number that is going to give out the AMP number. Okay, AMP 9 is the one that is going to hold this particular record with this row hash. If the value is repeated for 10 times, all those 10 values will go for the AMP number 9 only. Let's see in our query. The value is this one, right? Row hash value is this one. We'll get the bucket number now. This is my bucket number. Okay. If I want to know to which AMP this particular record will go, I have another function. If I insert a value 10 into the indexed column, it will go to the AMP number 1 in my system. So this is the function, or this is the query which I will be using to find based on the primary index column value onto which AMP the record will be inserted. This is the same replica of this particular slide. This function or this query is a replica of this. Whenever you are the row hashing algorithm is given with a value which is called as row hash value, it will give out a 32-bit value. In that 32-bit, the first 16-bit will be used to query this. It will be queried on this hash map, which will in turn give the bucket number, which will have the AMP number onto which the record will be inserted. Clear?
Yes, exactly. I got it.
Okay. This is the query. If I want to check whether my table is properly distributed, it is properly distributed or it's not properly distributed. I want to check like this. Okay. My customer ID is my primary indexed column. So I have 1000 records in customer table. Out of this, 503 records will go to AMP number 1 and 497 records will go to AMP number 0. Are they uniformly distributed or not? Almost uniformly distributed, right?
Correct.
Almost uniform, right? So it's not
Yeah, correct.
creating any problem in terms of distribution if I select the customer ID as a primary index column. Let's say if I want to change the primary index to age column, let's see how the distribution is going to be. You can do it on a trial and error basis. Even the age column is distributing in a good manner. 0 and 1. 499 records on one AMP and 501 records on another AMP. Right? It is also resulting in good distribution. Now let me check on Zender column. 431, 569. A bit bad, right?
Correct.
Now we'll check on this one.
So Chaitanya, the query that we are running, it doesn't actually look into the DDL for checking which is the primary index, or it just takes whatever column that we give.
It will check only the column which I am giving. It's not
Okay,
going
so
to take out.
internally, okay, okay,
I'm
so
just
but
checking it in the manner like which column is more better. Let's
okay,
say I have
okay,
an issue with my primary index column for my table. So I am
okay.
checking, I can check like this.
Oh, okay, got it, got it, got it.
If I
So, but
give
internally,
the
when
primary index on number of children, see the variation. 719 records on one AMP and it's loading 281 records on another AMP.
Okay,
My
okay,
system has only 2 amps. That is why it is showing 2 records. If I have 100 amps, it will show the distribution on 100 amps.
okay, okay,
So it could be a bad choice if I select number of children.
okay, yeah, correct, got it.
So who will decide the primary index initially? Here I am doing a trial and error basis, but in live, I'm not going to do it, right? Before creating it in production, before creating it in production, I should test this. I should have selected the best primary index, right? So
Correct, correct.
during the initial testing effort time, who is going to suggest? Initially, it will be suggested by the data modeler, who will be doing the source analysis. Based on the source, he will be suggesting the primary index column, right? Because he
Okay,
is the one who is aware of the data that is going to come into that particular table and on what factors I am going to access the table and on what basis I can able to easily identify the rest of the columns in the table, right? So he is
okay,
the one who can able to identify it correctly. So he is the one who is going to predict the primary index call. If it is causing any issue, then you can check like this using this particular query.
okay, okay,
This is the standard query. You can execute not only in the local system, you can execute in the live environment also. The one positive thing with respect to Teradata is whatever you practice on the local or the dummy environment, the same will you can replicate in the production live production system also. It's nothing going to change even by a single letter.
okay,
Okay. So this is the one I'll be using for checking the distribution. So
okay.
here whatever the customer ID that was chosen is good. Suppose if the first column is going to be a Zender column.
Then it would have been a bad idea.
Sorry.
Then it would have been a bad idea for making it as primary.
It may be a bad idea, right? If I have 10 amps, all the data will go only for 2 amps,
Correct.
right? So
Yeah,
in
correct.
general, what will happen is, in terms of some environments, whatever be the primary index columns they want to keep, they will keep in the starting. Why means if they forget also, if they forget to specify the primary index explicitly also, whatever be the primary index they have kept in the starting will be taken rather than the bad columns. So in
Okay,
some environments they will follow such standards, some may not.
okay, okay,
Okay. So here whatever be the value that we are passing into the primary index column, that is taken by the row hashing algorithm, and that algorithm is mapping that particular record to the amp in the system. So here in terms of insertion, that is the case. In terms of the retrieval, what it is going to do, if I say select star from employee table where customer ID equal to 123, in that case also it is going to, as I have mentioned the customer ID column in my where clause, customer ID is there in my where clause, and that customer ID is the primary indexed column, right? So that
correct.
value 123 will be passed to the row hashing algorithm. Similar, it will get out the row hash value, and from there it will pull out the hashing algorithm value, and it will give out. Based on that, it will reach to the AMP number and it will retrieve the record. In terms of insertion, it is the case of where the record should get inserted. In terms of the retrieval, it is from where the record should be retrieved. That is the difference. In both the
Okay,
cases, it is finding out the row hashing process and it's finding out the AMP number from where the record is going to be retrieved.
okay,
But
okay,
if I'm not mentioning the primary indexed column in my where clause during the select query process, during the retrieval process, how the record is going to be identified is the question, right? If I am
yes.
firing a query saying select star from customer table where age equal to 30, is it going to fetch me the record with the customer ID which I am expecting? It may or may not. If the age is 30, then only it's going to retrieve.
Correct.
Here, how it is going to identify the records of the age 30 means here I am not specifying the primary indexed column in my where clause. So it will check for each and every record of the table, whether it is of age 30 or not. If I want to use the performance of an index, you need to specify it in your where clause during the time of retrieval. Otherwise, the system cannot use the capability of the indexed column.
Okay.
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 So here I have mentioned one more thing like in this. When I said like if I am passing the value 10 for 10 times, it's going to give out the it's going to give me out the same row hash value, right?
Correct.
If it is giving me out the same row hash value, it will give out the same bucket number, right?
Correct.
If it is giving me out the same bucket number means it's going to give me out the same amp number, right?
Exactly.
So if there are duplicates in the values that were getting as an input to the primary index, means pro-hashing algorithm means if I am getting duplicates in my primary index column value because my defined primary index is non-unique primary index. If I am
Okay.
getting more duplicate, if I am getting duplicates, all the duplicates will be diverted to the same because they will result in same row hash value, right? If I'm
Exactly.
giving the value 10 for 2 times or 10 times or 100 times or 1000 times, it will always give out the same row hashing value, right?
Yeah.
If it is not the case, then it is not said to be an algorithm, right? So
Correct.
it will result in same row hash value and it will result in insertion of the record onto the same AMP.
Okay.
Why the number of children is a bad choice? Because 760 records are going into one AMP and 240 records are going to on the other AMP. It is leading to unequal distribution because there are n number of duplicates for each of the value, right?
Correct.
So if there are duplicates that were resulting in the insertion of the data onto the same map, which is causing unequal distribution of the data across the AMPs. In that case, it is called as an issue called skew factor. It is said to be a problem called skew factor. Okay? It
Okay.
is said to be a issue called skew factor. What is the reason for skew factor? Or what is the cause for the skew factor? Any guess? What is the cause for the skew factor? And what is skew factor? Can you guess?
Uh,
What is the
uh,
one that is causing the skew?
uh, because of non-unique primary index.
Because of non-unique primary index, the skew is getting caused. Because of
Yeah.
the duplicates you are getting in the non-unique primary index column value, it is getting skewed. So
Yeah.
what is termed to be a skew factor? What is meant by skew factor means how can you say? The unequal distribution of the data across the arms on the Teradata system is called as a skew factor. The reason for skew is the number of duplicates. If you are encountering more number of duplicates in the primary index column, then it will lead to unequal distribution of the data across the AMPs. That is the skew factor. You are three friends, let's say. Okay? You and you have two friends. You three are working on a particular work. Okay? You
Okay.
three people are working on a work. You are allocated to transfer some 50 cottons to from a room to outside. each person has to carry 50 cottons from one godown to outside of that godown, and you need to load it into a wagon.
Okay.
Okay, so you three people means each will have different capacity. Some can carry in a fastest manner, and some will move in a slower manner, right?
Yeah.
So the wagon need to be started once all these 150 cartons are moved out. Okay, if you all three have transferred those 150 cartons from go down to wagon, then only it will start. So
Okay.
being energetic, you are the person who can traverse it faster, and your second friend is a bit weak person, and he is a person of not of that much, what I can say, person capable to move faster or carry the things faster, or he is a bit lazy in terms of his walk.
Okay.
Okay, so in that case he is walking a bit slower. So what will happen here, you will be done with your 50 cartons migration and you will be sitting aside. Your first friend is also done with his work and he is also
Okay.
sitting with you. What's happening, almost all maximum number of cartons are moved, but still the wagon has to wait because one of the session is still working, means one of the person is still working, he is to complete his quota, right? Right or
Yeah,
wrong?
correct. Yeah, correct. Exactly.
Similarly, in terms of the data distribution here, okay, similarly in case of the data distribution here, the data has distributed non-uniformly. It has not distributed uniformly. On one AMP it has more number of records, on some other AMPs it has got less, and some other it has got a moderate number of records. So whatever be the AMP that has got less number of records is done with its work. Whatever be the AMP that has got more number of records to work for more time, right? So until that particular point of time, you can't say the query retrieval has been finished, right? So
Correct.
what could you say based on this scenario? Whenever the data distribution is not uniform, the retrieval speed will increase. Right or wrong? Because one AMP is working for most time and other AMP is working for less time. Right? If it is
Yeah.
uniformly distributed, we'll go by a general example, one more general example. If the data is uniformly distributed and if you are triggering a session job with n number of sessions, a session is nothing but the dedicated connection with the database. N number of sessions means a user is logging for n number of times. Means the
Okay.
login is going to be replicated with n number of times. Let's say if we are saying 5 sessions, whatever be the user ID and password you are giving, that ID and password are replicated for 5 times in terms of requiring 5 sessions with the database, 5 connections with the database to do the same work.
Okay.
And each of the session will work on each of the AMP in the system.
Okay.
Okay, like that it will, whatever the session that was allocated to each of the AMP, it will retrieve the data from that particular AMP. Here one session is working for most of the time and other session is working for less time. If all the sessions are done with the work, then only I can say all the data is retrieved. If any of the session is still working, means then it is not, I can't say like the work is completed. You are boiling 12 eggs in a vessel and one egg is having a problem. It is still boiling. Okay,
Okay.
or let's say you are cooking something and some portion of the rice is done and some portion is not yet, it's still watery. Will you say
Okay.
that cooking is done?
No.
Similar is the case. If
Okay.
you are boiling 12 eggs and for boiling one egg it is going to take 4 minutes. For boiling 12 eggs, what is the time it is going to take? For boiling one egg it's going to take 4 minutes. For boiling 12 eggs, what is the time it is going to take?
Uh, Ideally 48.
Sorry?
Ideally 48 months.
48 minutes, right?
Yeah.
For retrieving 100 records, it's going to take me 1 second. For retrieving 1000 records on a 10 amp system, how much time it is going to take? I have 10 amps in my system and there are 1000 records in my table. All the records are uniformly distributed. Okay? So each
Okay.
amp has got a chunk of 100 records on its as its chunk from the table. So 10 amps, 100, 10 into 100, 1000 records, right? So for
Yeah.
retrieving 100 records, it's going to take me 1 second. So how much time it is going to take me for retrieving 1000 records?
100 seconds.
100 records, 1 second. 1000 records,
10 seconds.
10 seconds.
Yeah.
So for boiling one egg, it's going to take 1 minute. For boiling one egg, it's going to take 4 minutes. For boiling 12 eggs,
Mm,
48 minutes, you
yeah.
tell,
Correct.
right?
Yeah.
So you have, tomorrow it is Sunday. Me and Ishwar came to your house for lunch. Okay?
Okay.
So we have asked you to have an egg for as part of the lunch. We don't want to have chicken or mutton. We plan to opt for a egg. So will you go and cook one egg and give it to Ishwar? Then again you'll go back to kitchen and you'll boil another egg and you'll give it to me. And again you'll go
No.
back to kitchen and you'll boil another egg for you.
No. Put everything together.
Then if it is that case, all those for 12x going to take 48 minutes or 4
No.
minutes.
4 minutes. Yeah. 4 minutes.
That is the case, right? So for
Yeah.
retrieving 100 records, it's going to take me 1 second. For retrieving 1000 records on which are distributed on 10 amps, it's also going to take 1 second only, right?
Okay.
If
Okay.
if the data is uniformly distributed across the amps in the system, right?
Okay. Okay. Yeah.
It
Correct.
could be the case where the data is uniformly distributed across the system.
Okay.
If the data is not distributed uniformly, in that case, it
The
is
time
going to
may be.
take more time. So the
Correct.
problem with the skew factor is going to be increase in terms of the retrieval time. It could increase the retrieval time of the data
Okay.
because data is not distributed uniformly. Clear?
Yeah. Correct. Got it.
Okay. Okay. Rajesh, will have a break for 5 minutes, then we'll continue. Okay?
Yeah. Yeah. Sure.
Oh,
I guess space. No, in between primary index and
yeah,
date.
yeah, yeah. As keyword and the select keyword. Just a second.
Yeah.
This is the thing that is wrong. I shouldn't place like this. Primary index with the data. This. So now I need to specify whether I want to copy the structure of test 21 with the data or without the data. If I don't want the data, then you need to mention it as with no data. Then it will not copy the data. It will copy only the structure. So here I am saying like if there is any data, copy the data as well into the test 20 table. Now it has created,
Okay.
right?
Okay.
So in this way also you can create it.
Okay.
Okay, like
So we
this.
first
Yeah, go
take the
ahead.
backup. So we first take rename the existing table and
Yes,
either use the same DDL and change the primary index and then create it using
yes.
DDL,
Then you need
or
to create it, then reload the data and drop the backup portion of the table.
yeah, or drop the take a backup and then and
Create it
from the
explicitly with the new create explicitly with primary index on the new column. Then create it the backup portion of the table. Then create it, drop the backup portion of the table.
okay,
Why
okay,
you
okay,
need to drop the backup portion? Because if you are storing the data in the new column, then you need to drop the backup portion of the data.
correct, correct,
If you feel it is needed, you can keep it. Especially if you want to use it in the memory.
okay,
For as you are not going to use it in the long run, rather than this, there is no other option of doing it by means of a alter table. The skew factor is the problem. So how to overcome the skew factor? Who is working? I want the record of employee number 10. Rajesh,
hello, you sure?
I lost the
Yeah, I can
presenter
see, I can hear you,
privileges.
but
Yeah, actually I have
Ishwar?
lost the presenter privileges.
Oh, okay. Ishwar?
Ishwar, Ishwar. Okay.
You click on show your screen. On only one presenter. Click the center button. Yeah, click the center button, Rajesh. You have three icons at the top, right?
how to transfer the presenter control? Just stop sharing my screen.
Yeah, Rajesh, I got it.
Okay, okay.
Okay. So in terms of, hello,
Hey, I can hear you.
Rajesh.
Yeah, I can hear you, Saksha. Can you hear me?
Yeah. Yeah, you're able to see my screen, right?
I can see your screen.
Rajesh, you're able to see my screen, right?
Yeah, I can see your screen. Can you hear me?
Yeah, I'm able to hear you. So the issue is when I try to refer to a particular record, I am seeing more number of records. So if I'm able to identify my desired record uniquely, I could be able to reduce the effect of skew factor, right? If I am having a, let's say
Yeah.
my employee ID is given in my company based on the department number. The employee ID starts from 1 in department number 10. Again, the employee ID starts with 1 in department number 20. Okay. And for department number 30 also the employee ID will start with 1. So here my primary index is on employee ID itself. So if I want to identify the employee with employee ID 10, it could give me more number of records, right? Along with that, if I'm specifying the department number also, where I'm specifying like select star from employee ID, select star from employee table where employee ID equal to 10 and department number equal to 10. It's giving me more accurate, right,
Yeah,
Rajesh?
fine, exactly. Yeah, exactly.
Yeah. So it's giving me in more accurate manner. So rather than filtering n number of records, I am filtering out the most desired record for me. So this is how I can reduce the skew factor. So here if I am accessing that table also by means of another column which is on department number. So how can I effectively use this department number and how it is able to identify the record more uniquely because of this department number means if the column is defined as a secondary index column. Okay. If the column is defined as a secondary indexed column, then I can able to identify the record more uniquely. So like here, I'm creating another index on this particular table in order to reduce the skew factor, right? So there
Okay,
I
okay.
can, based on the other index, I can able to identify the record more uniquely, which could help me out in retrieving that data more faster. So when I say create secondary index, okay, secondary index is the solution in case if you have a more skew, if you have a table which is highly skewed, and if there is a case of not, if it is not allowed to change the primary index of the table, okay, the solution is going to be the secondary index. Clear? So before moving into the secondary index, we need to know like what are the possible cases that will lead to make a column as a primary index. So what are the cases or what are the considerations that I will be using to make a column as a primary index? If it is changeable or not, it's a second aspect. But what are the conditions I will be looking at in order to have a candidate or a column that is ideal to fit as a primary index that shouldn't run out into the skew issues is try to select a column that is more unique in it. If it is not possible to have a column or if there is no column that is entirely unique in the table, then try to select the utmost unique column to the max possible extent. Whatever the more unique column in the table, try to select that particular column as the primary indexed column, so that it will not lead to skew factor.
Okay. Okay.
Clear?
Yeah.
It
Okay.
so that it shouldn't result in skew factor. So the
Okay.
second consideration is going to be, try to select a column that is more stable in nature. Why you need to have the stable column as a primary index?
By stable, you
What
mean?
is the stable column? Means the column that is going to be less subjected to changes. Means less, the column that will be updated with less frequency. You shouldn't be updating
Okay.
that column with much frequency. Okay? So
Okay.
you should
Okay.
choose
Okay.
a column that should be less frequently updated.
Okay.
What could be the reason? What is the relation between frequency of the frequency of the updation of the column and the primary index choice? Means, let's say if you have updated the primary index column value from 10 to 20, what will happen? If you, let's say the value with employee ID 10 is existing on AMP number 1, and record number, if the primary index is 20, it is getting stored on AMP number 2. By means of an update statement, I have updated the employee ID 10 to 20. There is a change of primary index, so it should again undergo the row hashing process, and the record should be moved to AMP number 2, right? Because AMP number 2 is the one that is the designated AMP, where AMP, if the employee ID is 20, the record should be inserted, right?
Okay.
So if there is a change in row in the primary index column value, it will again undergo the row hashing process. Okay?
Correct.
It will again undergo the row hashing process, and there could be a possible in terms of it is getting stored in the new AMP. Even if it is getting into the same AMP also, it will undergo the row hashing process, because there is a change in
Data. Primary index.
row hash value. So there could be a change of data from one AMP to another AMP. If you are updating the table, if you are updating the bulk volume of records in the table, which is of a huge size, and if you are updating on the primary index column, what will happen? There will be a shuffling of records that will be happening from one AMP to other AMP because of the new value that was given to the primary index column, right?
Correct. Correct.
So this increases the network traffic because of the records movement across the AMPs, right?
Okay. Okay. Yeah. Correct.
So it will increase the network traffic. If the network traffic is huge, means there could be a possible slowdown of the system.
Okay. Okay.
If it is a smaller table, it is fine. If it is a table of 5 terabyte, it will
Then it will be a,
consume huge amount of system resources, right?
exactly.
In terms of the
Exactly.
network, could be 5 terabyte table, means it could be having millions and billions of records. So if there is a traverse of that many records, means it could be
It
a,
will be
it could cause a slowdown of the system,
correct. Correct.
right? And the
Exactly.
other scenario is, try to select a column that is more frequently accessible. Try to select a column that is involved more in the joins, or that try to choose a column that is getting more frequently accessed when you are accessing this table on the column that is the base, or the column that is more frequently involved in the join condition.
Okay. Okay.
The reason is, if you are choosing a column that is less, on which you are accessing the table very less with less frequency, you can't able to use the capability of the index, right?
Correct. Correct.
If you are using a column that is that if you are using a column or selecting a column on which you are regularly accessing the table, let's say the customer ID column, or the employee ID column in employee table, right? If you are using that
Okay.
particular column, then you can able to use the index performance more effectively, and
Okay.
the number of records you are processing is also going to be less.
Okay.
If you are making the employee ID column as the primary index, the volume of records you are going to process will be one or few, right?
Okay. Okay.
So if that is the column you are making as a primary index, means if that is the column that is frequently getting involved in the join conditions whenever you are joining this particular table with other table in the system, then the join condition itself will retrieve in more faster manner, right?
Okay.
If it is
Yeah,
a
got
join with
it.
index versus index, then it could be evaluated more faster, right?
Okay. Okay. Yeah, correct.
So these are the three reasons we need to be aware while selecting the primary index. The most stable column, the column which is
Updated less
more
frequent.
unique, and the most frequently accessible column in the table, which is getting involved more in the joins or which is used more in the where clause. So
Okay.
these
Okay.
are the things you need to look at when selecting the primary index of a table. Clear?
Uh, okay. Okay.
Rajesh,
Yeah,
clear?
got it. Yeah,
Okay.
got it. Check it.
So coming to the reduction of the skew factor issue, we need to use the secondary index.
Okay. Okay.
Okay. In terms of secondary index, also we have two types of secondary indexes. One is going to be the unique secondary index, and other is going to be the non-unique secondary index. Okay. One is going to be the unique secondary
Okay.
index, and other is going to be the non-unique secondary index. So I can create a secondary index at any point of time by means of a create index. Let me show you.
Okay.
Here it doesn't have any secondary index, right?
Yeah.
Now let me create a secondary index. Create index on age column. If I am sure that it is going to have unique data, I can place a unique keyword here.
I guess the existing
Oh,
index is
already I
already
have
ready.
created the age column as primary index, right? Now I
Yeah.
am going to give it on. Okay. So here
Okay.
I have mentioned index, right?
Okay.
If I want to have a unique secondary index, I need to prefix the index keyword with unique, create unique index on column name on the table name. If I don't
Okay.
want this one, I can drop it. I can create the secondary index at any point of time, and I can drop it at any point of time.
Okay.
It
Okay.
doesn't harm it. It doesn't harm my system. So when I fire a keyword, when I fire a statement like this, create index or unique index on table name, on column name, on table, with a column name on table name, what will happen internally is when I create this, it will automatically create a secondary index subtable. What will happen? It will create a secondary index subtable. This is the base table which we are accessing, and when I say create index, it will create a secondary index subtable on all the AMPs in the system. Okay. When I create a secondary index, it will create a secondary index subtable on all the AMPs in the system. and it will load the data. Who is responsible for loading the data into the secondary index subtable? The responsibility of loading the data into secondary index subtable based on the base table will be taken over by the system. Okay. When
Okay.
I fire this create index statement, it will immediately create this secondary index subtable and it will populate the data in the subtable based on the data in the base table. Whatever be the qualifying records or whatever be the records that were there in the base table, based on that, it will populate the secondary index subtable. Okay.
Okay. Okay.
So in the secondary index subtable, you are going to have three columns. Like the normal table itself, you'll have the secondary index subtable also distributed across all the amps in the system. Okay, it is going
Okay.
to be distributed across all the amps in the system. One more thing I forgot to tell you is, whenever the record is getting inserted onto the amp, okay, it will never identify the record based on the values in the record. It will always identify the record based on the row hash value of the record. Okay, it will be identified based on the row hash value of the record. So along with the data record, the row hash value will also be stored on the amp along with the data record. Okay, along with the data record, the row hash value will also be stored on the amp along with the data record.
Okay.
If because of having non-unique primary index, another record is also resulting in same row hash value because of the non-unique primary index I'm having. So
Okay.
if it is resulting in same row hash value, should it override the existing record on the AMP? If it is happening, it is going to be a data loss scenario, right?
Oh yeah, correct.
So if it is resulting in the same row hash value and if I want to handle the record, how can I store it? Is the question, right? How
Okay.
can I
Yeah.
store it? In that case, it is a problem called hash synonym, or you can also call it as a hash collision. When two records are resulting in same row hash value, might be because of same value or two different values are also resulting in same row hash value. Okay, that type of scenario is called as a hash collision, or you can also call it as a hash synonym. So I want to store both of the records on the AMP. So how come I am able to handle this situation? So how Teradata is going to handle this situation means the row hash value is of a 32-bit, right,
Yeah,
Rajesh?
correct. Yeah, correct.
So here if you see in this example on the slide, 1254 is resulting in this row hash value. Similarly, 7769 is also resulting in same row hash value. So same records may result in same row hash value or different records also may result in same row hash value. Okay. So how can I handle is there is a concept of uniqueness value. Teradata has come up with a concept of uniqueness value. Okay. So initially
Okay.
the uniqueness value will start with 1. So whenever the records are not resulting in same row hash value means the row hash value getting generated is different, then till that particular point of time the uniqueness value will be 1. If any of the record is resulting in the same uniqueness in the same row hash value means if it is encountering a collision, then the uniqueness value or the uniqueness value for that particular record will be incremented by 1. Okay.
Okay. Okay.
So along with the row hash value, the uniqueness value will also be stored on the disk. So the uniqueness value is also going to be a 32-bit value. So the value of the 32-bit value of the row hash value and the 32-bit value of the uniqueness value will make a 64-bit unique ID, which we will call it as row ID. Okay, which is
Okay.
a row ID. So the Teradata record identification mechanism is based on the 64-bit row ID. Row ID is nothing but a combination of row hash value and uniqueness value. So it is making more
Okay.
unique in terms of identification, which is going to be a 64-bit row ID. So whenever it encounters more collisions, the value of the uniqueness, the value in the uniqueness value column will keeps on incrementing so that it can accommodate all the records on the AMP.
Okay.
Okay. So you might get another question saying that on a particular AMP, on a system we will be having n number of tables. All n number of tables will be distributed across all apps in the system, right? So if I am having n number of tables means on the same
Right.
AMP also there will be a number of tables records, right?
Correct.
But here any tables data will not the tables data will not be mixed with any other tables data. The data of a table will never shared with the or sorry will never mixed up with the data of another tables. What happens is internally the data memory the data sorry the memory in Teradata system is organized in the form of blocks. So whatever
Okay.
be the data whatever be the tables data that was stored in a block will never be used by the other table in order to store its data. You went for a shopping mall. You have n number of counters of n number of brands. You have a brand Pepe and you have a brand Reebok. Will the brands of Reebok will be kept in the stall of Pepe? Will they
Hmm.
be organized in that particular stall?
No. Don't think
No,
so.
right? There you can see shoe. Let's say you have a Wrangler stall. So in Wrangler stall you have the jeans of 32 size, which is a denim blue. In Pepe also you can see a 32 size of 32 size jeans of denim blue. Will they be kept in the same stall?
No.
Being a different brands, they will be kept in different blocks, different
Correct. Stalls.
stalls, right? Similarly, the data of one table which is stored in a block will never be shared with the other table in the system. Okay? So it will never
Okay. Okay.
mix. Okay? So in a
Okay.
block, the records, whatever the records that was stored is of the same table. So on a AMP, along with the data record, it will also store the row ID of that particular record. Okay. So when a system comes in terms of identification, it will never check with the data whether it is employee number or last time you are using. It will identify the record based on row ID. How you will be identified in your company? Based on your employee ID, right?
Correct.
If I
Correct.
say Rajesh, there could be 10 people with the same name, right? How you will
Yeah.
be identified uniquely? You will be identified
Employee.
based on your employee ID, right? Similarly,
Yeah.
the record will be identified based on the row ID. The system will never check for the values.
Okay.
Clear?
Yeah. Got it.
So, oh, it's already 9, right? So, at what time you are planning in the evening, Rajesh?
Uh, Anytime after 2 o'clock, Chaitanya.
2
You can.
o'clock, right?
Yeah, and I mean, anytime after 2 o'clock is fine. Whatever is
4
convenient
or
for you.
2?
Anytime after 2 o'clock is fine for me.
So, can we have a session at 2 to 3?
Yeah, not a problem.
Because I have to take my daughter to a doctor in the
Yeah,
evening.
yeah, yeah,
So,
not a
we'll
big
have a
deal.
session at 2 to 3. Okay.
Yeah, sure,
In the
totally.
evening, you told like it will be okay if we have the session at 9 o'clock, right?
Yeah, after 9 or would be better after 9:30.
9:30 will be too late. As you told yesterday at 9 o'clock, right? You will be reaching home by 9 o'clock, right? So if
Yeah,
it is
between
9:30, it
8:30
will
and
be
9.
difficult for me. If it is 9 o'clock, I can able to adjust 10 o'clock, right? 9 to 10 is fine for
Okay,
me.
fine. Yeah, not an issue. I will accordingly adjust reaching from
You'll
office.
be able to reach and able to join by 9 o'clock, right?
Yeah, yeah, yeah. I can do
Yeah.
that.
Okay, we'll have a session today at 2 to 3 and I'll let you know when we can start from 9 o'clock. Okay?
Yeah, sure. Yeah, sure.
Yeah. Thank you, Rajesh.
Yes,
We'll meet
yes,
at 3
thank you.
o'clock. Sorry,
Yeah,
2 o'clock.
2 o'clock.
Can you
Yeah,
ask
okay.
Ishwar to send out or to open the bridge at 2 o'clock?
Yeah, sure. I'm going to class at 10 o'clock, right? So I'll inform him.
Okay. Yeah. Thank you.
Yep, thank you.